Hi, welcome to Technical and Engineering Academy. This is Blessed Elvis. So let's do the integration using the partial fractions. Now, the partial fractions equations, or rather the fractions where you have the degree of the denominator being greater than the degree of the numerator. So that's one way of identifying whether the given expression is a partial fraction. So what do I mean? You have the highest power of the variable in the denominator than you have in the numerator. Then that tells that that's a partial fraction. So let me give an example of a partial fraction. Let's say where you have 3x minus 1 over x squared plus 4. So since the power of x here is greater than the power of x on the numerator, then this entails to say this is a partial fraction. If you have, let's say, 3x, now it's only x, however, x is the most common use, but it's not actually x only. So let's say you have this, minus 3, and then down there you have, let's say, t power 3 plus 4. So in this case, since the denominator has the highest power degree compared to the numerator, then this entails to say this is a partial fraction. So this is one way of identifying a partial fraction. When you are given the numerator having the less degree of the variable present, then you know that that's a partial fraction. Now, we are going to deal with fractions here to integrate the given expressions in form of partial fractions. So in this case, let's look at the examples. So make sure that you have a very good background on partial fractions. If you don't, I have made a video on partial fractions, so make sure that you watch that one. However, don't worry, we are going to discuss as much in detail as we can so that you can even have a clear picture on partial fractions. So let's say you have an example where you are given to say 5x minus 4 over 2x squared plus x, then minus 1. We integrate this with respect to x. So how can we integrate such an expression? So since we have the degree of the denominator being greater than the degree of the numerator, then in this case we are going to use the partial fraction rules. So before we integrate such an expression, you first have to express this, or rather simplify this in the form of the partial fractions. So at the moment we will ignore these and then just remain with the fraction. So the fraction that we have is 5x minus 4 over 2x squared plus x minus 1. So according to partial fraction rules, you need to equate this to certain unknown values. Now, the unknown values are determined by how many, or the number of the degree you have here. So if you have the highest degree being 2, it means you are going to have the unknown 2 values. If you have the unknown 3 values, it means here you have how many? 3 as the degree order. If you have 4, just likewise. So in this case then, we only have 2 as the highest degree order. So this implies that the unknown values can be represented by what? A, capital letters A. So in this case it's A and what? And B. These will be our unknown values since we have only 2 as the highest degree order. If you had 3, it could have gone up to C. Okay, it could have gone up to C. So in this case then we are just going to have A and B since we only have 2 here. Now, how can we write this? We write this in form of fractions. Here we have the unknown values, okay, plus b over the unknown values. So our main point now is identifying these unknown values here. Okay, so how are we going to identify these? by simplifying this. So how are we going to simplify this? Let's try to factorize the denominator first. Okay, so factorizing the denominator, okay, let's just let this be. If space will not be enough, we will then get rid of them. So factorizing the denominator here, okay, we have plus x minus 1. Let's find the product, the sum, and the factors. We know that to find the product, you multiply the coefficient of x squared with the constant number, which is negative 1. So negative 1 multiplied by 2, it's negative 2. So our product is negative 2. And then the sum, you only get the value of the x coefficient. So the value of the x coefficient in this case is just 1. Okay? And then the factors are the numbers you find which you can multiply to have the product, and then when you add the same values, you have the value of the sum. So which numbers can we multiply for us to have negative 2, and then when we add the same numbers, we have 1. Okay, so it's what? It's 2 and negative 1. So in this case, you are going to replace where there is x coefficient with these that we have found here. So in this case, our expression will now become 2x squared, then plus 2x, then minus. Now 1, it's the same as a given variable which is present in the expression. So instead of writing 1, we are going to write the variable which is present, that is x, then minus 1 here. So then we have to simplify the given expression. So in this case, let's just get rid of this. Hopefully you have taken note of this somewhere so that you might not be confused later as we keep on answering. We might be getting back to some of them. So in this case, then we have 2x squared plus 2x minus x minus 1. So in this case, we can simplify this. So let's factorize 2x here since it's common. So we are going to have 2x, and then here we are going to remain with 1x because we have only gotten x, and here we have 2x. So if we get 1x, which is here, and then here we are going to remain with 1x here. So after we remove 2x, we're just going to have 1 because 2x multiplied by 1 is just 2x. Then here, there is nothing that is common, only the negative, so it's just negative. If you want, you can include 1 because 1 does not affect anything. So it's x here plus 1 because negative 1 multiplied by x, it's negative x, and then negative 1 multiplied by positive 1 is negative 1, so it's just the same thing. So that's how you can simplify that. Okay, so this needs a lot of information, So this is quadratic equation where we are using the factorization method. So in this case, we have this and that are common, so we are just going to write 1. So those are known as common factors. So we are just going to have x plus 1, and then we write the expressions that we have outside the brackets. So we are going to have what? 2x minus 1. So these are our simplified unknown values. Remember, so let's just take note of these values. So remember we had a over unknown values and b over known values. So the expression that we had was 5x minus 4 over what? Over 2x, okay, 2x squared plus x minus 1 equal to a over unknown value which was represented by n plus b over unknown value which was also represented by n. Now, where there is this quadratic equation, we have already found that there is what? There is, of course, x plus 1 and also 2x minus 1. So here, on the unknown values, where we have these, we are going to replace with that. So firstly, the first unknown value on A will be what? X plus 1. And then secondly, where there is a known value on part of B, we are going to have 2x minus 1. So in this case, then we are going to have A over x plus 1 plus B over what? Over, in this case, 2x plus 1, sorry, here. So 2x, then minus 1. So this is our fraction here on the right part. Now, the main point again is to find the values of A and B. Okay, to find the values of A and B. So how can we do that? So in this case, this part here, okay, let me just rewrite all of this for the sake of space. So we have 5x, or rather what's that? So 5x minus 4 over, here we have x plus 1, and then here we have 2x minus 1, okay, equal to a over x plus 1, and then b over 2x minus 1. So in this case then, let's find the common denominator here on the right side. So here we are just going to have what? 5x minus 1 over x plus 1, and then here we have 2x minus 1. So in this case then, our common denominator will be the multiplication of the denominators here. So what are we going to have? We are going to have x plus 1, and then on the right side you have 2x minus 1. So when we divide this x plus 1 into this fraction, of course we know this and that will cancel. So when that cancels, of course we are just going to have what? 2x minus 1. So in this case we are going to simply multiply 2x minus 1 multiplied by a, okay, then plus, in this case when we divide 2x minus 1 in here, we know that this and that will cancel. So in this case we are just going to remain with what? X plus 1. So it's going to be b x plus 1. Okay, so we have that. So in this case we can see the denominator here and the denominator there are the same, so we can simply cancel them out, so that here we just remain with the numerators. Since the denominators are the same, that's why we have cancelled them out. So in this case we are just remaining with the numerator. So we can now write this. We have 5x minus 1 equal to, okay, let me just write a here, a, and then we have 2x minus 1, and then plus b, then here we have x plus 1. So we can multiply throughout the values of a and the value of b. So let's do that. So remember, on the right side we have 5x minus 1 equal to, when we multiply 2x plus, or rather 2x multiplied by a, we are going to have 2ax, then minus, when we multiply a with 1 here, negative 1, we are going to have negative a. So we have that. Then plus, when we multiply b with x, we are going to have bx, plus, when we multiply b with 1, we are going to have what? We are just going to have b. Okay, so let's rearrange this. We are going to rearrange this in such a way that the values that have x will be on one side, and the constant values which do not have x will be on the other side. So in this case we are going to have 5x minus 1 equal to, so in this case we are going to have 2ax, then plus bx according to the sign that's on b, then here we have positive b, and then here we have what? Negative a. Okay, so this is the same as having 5x minus 1 equal to, so we can factorize what? X here. So we're going to have 2a, then plus b, okay, then x here will be factorized outside, then here we have what? B minus a. Okay, so we have that. So how can we further find the values of a, or rather simplify that further so we find the values of a? So in this case, as we can see, this expression here has x, and the one that has x here is what? Is 5. So in this case, we are going to have 5x. So you separate them, the constant number with constant variables, the one that has x with what has x here on the left side. So here we are going to have what? 2a, okay, and then plus b, okay, and then x. And then we are going to separate this with the constant number here. So the constant number will go with the constant values, that is b minus what? Minus a. So we know that this x and that x can what? Can cancel. So if that cancels, it means we are going to have 5 equal to what? 2a plus b, okay, plus b. And then on the right side, you are going to have a negative 1 equal to what? B minus a. So what we have up there is the is the simultaneous equation. So in partial fractions, there are a lot of things that are involved. One, the quadratic equations, or equations generally, because you might even have a polynomial, and also simultaneous equations where you find the values of a and b. So rewriting this, of course, we know this is the same as 2a plus b equal to 5, and then here we have what? Negative a plus b equal to negative 1. So that's the simultaneous equation that we have there. Now, how can we simplify this, or rather, how can we find the values of a and b? So there are two methods. One, there is a substitution method, and there is also elimination method. So in this video, I'm going to use elimination method, but if you are familiar with substitution method, of course, you can use that one as well. So according to elimination method, you introduce this boundary here, and then since we have the same values here, what I mean is we have b and b there, and then the signs here are the same. It means I'm just going to make one negative. So I'm going to just introduce positive and negative there, so that here I will have negative, and then b and b will cancel. So positive multiplied by throughout in here, of course, we are just going to have what? We are just going to have the whole fraction the way it is here. It will just come out the way it is. Okay, equals to 5. If you want, you might even add 1 here so that you are not confused. So that you have positive 1 multiplied by 2a, you have 2a. Positive 1 multiplied by b, you have b. And then positive 1 multiplied by 5, you have 5. Okay, so then we come here down there. So negative and, okay, negative and negative there, we are just simply going to have, we're just going to simply have what? Positive a. So it's going to be a, and then positive and negative, it's just negative, and then here you have b, and then negative and negative, we are going to have what? Positive. Okay, so let's just create space up there. Okay, so it's quite a very long procedure, but if you are following up, it's very simple actually. So in this case then, we have that. So of course, according to elimination method, we are going to add on this part. So 2a plus a is what? 3a. Okay, so 3a, and then b minus b subtract b, we are going to have 0, so it's going to be, then 5, we add 1, we are going to have what? 6. So in this case, we are going to have 6. Okay, so when we divide 3 to both sides, we are going to have 3 here and also 3 there. So we divide this, we are going to have a equal to 2. So our value of a is 2, and then we can replace in one of these fractions. So remember, our a is 2, so we can replace. So we have 2a plus b equal to 5. So where there is a, we replace with what? With 2. Okay, then plus b equal to 5. So 2 multiplied by 2 is 4, plus b equal to what? Equal to 5. So we are going to take 4 to the other side so that we can have 5 subtract 4. So in this case then, it's going to be b, then 5 minus 4, of course, just 1. So in this case, we have our values of a equal to 2, and then b equal to what? Equal to 1. So let's now get back. Remember, what we had was 5x minus 4 over what? X plus 1. Or rather, let me just write the quadratic equation. So that's 2x squared, and then plus x subtract 1 equal to was a over x plus 1, and then plus b over 2x minus 1. So this was our expression. Now where there is a, we have already found that that's what? 2. So we replace. So we have plus 1. Plus, where there is b, we have 1. Then we have 2x minus 1. So this is our simplified expression. So where there is 5x rather minus 4, and then down there we have this then plus x minus 1. We can simply replace with that. It's just the same thing. So wherever we have this, we will replace with what? 2 over x plus 1 over 2x minus 1. So that's how we will go about this one. So in this case then, remember we had the integral of 5x minus 4 over 2x squared, then plus x, then minus 1 here with respect to x. So this time we have already found that where there is this, there is what? Okay, there is 2 over x plus 1, and then we have plus, so all of these plus 1 over 2x minus 1. Okay, all of this with respect to what? To dx. So in this case then, to dx here. So in this case then, we can integrate this separately, where we have the integral of 2, then x here, plus 1 with respect to dx, then plus the integral of 1 here over 2, then x minus 1 with respect to what? To dx. So we can integrate these individually. Now, what is the integral of this? So we know that if we take 2 outside here, we are going to have what? 1 over x plus 1 here with respect to dx, because 2 multiplied by 1 is simply 2. So we have just done that for the sake of simply integrating that without any issues. So let me just write that. Okay, let me just create space up there. Hopefully you are following up. It will be my great joy that you get the concept and understand all of whatever we are doing here. Yeah, it might be a long process, but it's quite simple if you just follow up. So let me just write this up there. So we have 1 over x, then plus 1, okay, then dx, plus, okay, 1 over 2x, then minus 1 dx. So this is what we have here. So let me just wrap what we have down there. Okay, so let's integrate this. Now, here we can use substitution method for us to integrate this. So previously I did a video on substitution method, integration with substitution method. So make sure that you watch that video so that you can have a clear picture here. So what we have to do is let the algebraic expression which is down here. Okay, so okay, the algebraic expression which is down here, you equate it to a certain single variable. We can in this case say just t. So after you do that, of course, let's say t equal to x plus 1, then you differentiate this expression. Okay, not even going this very far. Okay, of course, according to logarithmic rules, when you are differentiating or rather integrating a fraction which has 1 as the numerator, then down there you have an expression which has the power degree of 1. Of course, you have to use ln. So integration of this side here, we are just simply going to have what? It's simply going to be 2 ln of whatever we have on the denominator. The 2 is the one that's out there. So that's how we integrate this part here, and then plus, of course, we know this side now it's going to be what? Half ln of whatever we have in the brackets here. Okay, and then plus the constant c. So this is the answer for the question that we had. So this is how we go about the partial fractions. You can simply pause the video and copy these general antiderivatives of different kinds of expressions. Thanks once again, guys, for staying this far. Please like, subscribe, share, and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.